evening and welcome to the February 2025 meeting of the Madison DX Club. And tonight we're going to be talking about hunting down RFI sources in and out of your shack. This is part two. Part one was back in September. So Bob, would you introduce tonight's speaker?
Sure, my pleasure. Yeah, it's great to have Mike back. He gave us a great presentation back in the fall. Gosh, I think we had nearly 100 attendees for that meeting. And I got a lot of really wonderful comments on that presentation. And we asked Mike to stretch it out into another program. So we're going to do part two now. And this is going to be posted on our YouTube. And last I looked, Mike had 1,600 views of his September program. So people have really valued that. We're lucky to have him here because he's a very busy man. Every time I talk to Mike on the phone, he's somewhere else in the country. He's running all over the place, fixing people's problems or giving seminars. So welcome, Mike. We look forward to hearing your part two. Go ahead, Mike, whenever you're ready.
Thank you, Bob. And I appreciate your comments and appreciate everybody viewing what I did. I've been quite reluctant to do this for a very long time. I've had a lot of requests for this, especially since COVID. And I don't know, I'm not sure if it was Doug or Bob or who it was that called me originally, but I don't know, you must have said something good because it got me doing it. The last program was primarily about power line noise, as I remember it. And you have to excuse me, I do a lot of training classes, and I may make a few mistakes as to what I did before and what I'm doing now. But at any rate, I got a few very interesting things I think to cover. And one of the things that I did, I kind of took a few notes about the calls I've gotten since the last presentation, and I wrote down a few things as far as questions that people had that didn't necessarily pertain to the last presentation, but about the one in the future. So I hope I get all those answered. These topics, this stuff with RFI can get extremely deep and involved. And I've done my best over the past 45 years since I started doing this to try to keep it as simple as possible because that keeps my life simpler and keeps me from having to spend weeks of time at a place other than my own home. So what we're going to talk about here is trying to get the questions answered. And for the most part, inside noises. I may drift into outside noises from time to time, but hopefully everybody will get what they want out of this. One thing I wanted to mention is I don't get into the filtering process of noises almost never, other than my own vehicle, because it requires an enormous amount of time. And time is of the essence in what I do. So mainly what I do is locate sources. If I can de-energize the source, then I know I've located it. One thing that I don't do is say this is what the noise is without being able to turn it off. It's very easy to point the finger. And I see this in almost every investigation that I do. I see someone has pointed the finger at something that didn't turn out to be the cause of the problem. And that gets very expensive for everybody involved and also causes enemies, a lot of enemies. So with that speaking, a couple of statistics. When I started doing this back in the 70s, I had to write a report. I worked for a power company and I had to write a report at the end of every month. And back then, the numbers really didn't mean anything to me, but I think it's pretty amazing the statistics that were involved. I kept track of the number of complaints. I kept track of how many complaints were caused by the power company, how many complaints were caused by non-utility equipment, and basically, or not basically, but the fact is, when I started doing this, I was closing 32 complaints a month. Oh no, I'm sorry. We were getting 32 complaints a month. Sometimes I only closed 4 or 5 a month because I wasn't very good at it. But this utility got 32 complaints a month on the average in the first few years I was there. And the main reason for that is the people that were doing it, including myself, didn't know what we were doing. And that's still a big problem all throughout the country. Most utilities are in that type of situation. And that exists because there isn't enough of this. There just isn't enough for them to warrant one person doing it all the time. There's probably 4 or 5 countries that I could name off the top of my head that have somebody dedicated to this job full time. I have over 4,000 clients in my database that I deal with. And to say there's 4 or 5 companies that have one person dedicated to doing just this is a huge ratio. I mean, it's amazing. Um, but all those people that don't have one person are in the situation that most of you guys experience. People coming out, they come out once, they don't come back that day. They might come back 6 months later. It's really terrible. So one thing I want you guys to know is it's very important that you stay connected to your utility. If you experience RFI, they will never get good at it if you don't keep squeaking, you know. The squeaky wheel gets the grease. If you don't squeak, they don't hear it. And that's just the way it is. I would have never gotten to this level if it weren't for customers being so adamant about getting their problems resolved. I guess I can take a little credit. I was willing to teach myself how to do this stuff and get help. But it's very, very important that if you guys think you have noise, call the utility, get them busy, and stay on them. It's very important. You know, as you all know, it only takes one noise to wipe out your communications, and sooner or later that tends to happen on a day when you need it the most. So, part 2 is it power line interference or is it non-utility equipment interference? What I want to do is show you some pointers on how to figure that out and what to do if you do figure that out, as well as a few mistakes that are made along the way. And it's very common for there to be mistakes along the way by the utility and by the customer, or in this case, amateur radio operator. Okay. It's very important. Call your power supplier, call your utility when you realize that you have RFI that could possibly be coming from the power lines. You don't know it is, don't know it isn't. And believe me, it does them a great service to have the opportunity to look for it, even if it isn't theirs. They get better at it by looking for things that aren't theirs. When I did this for a utility as an employee of the utility, 80% of the sources that I looked for were not utility-owned equipment. 80% of the sources were on neighbors. Most of those, out of that 80% that was not utility-owned equipment causing the problem, out of that 80%, 80% of that 80%, sounds kind of funny, 80% of that total was found to be in the resident of the person complaining. So that's a big part of this thing. It's realizing that pointing the finger doesn't do you any good. It's hell eating crow, you know. And most people have a tendency, or most people do eat crow sooner or later. Okay, remember, if you call the utility and complain about a noise, and they come out and prove it's not, or let's say after you call and complain, you realize that the complaint you just made, it isn't caused by the power company. That's okay. To your credit, call them and say, hey, I'm sorry, I've located the problem. It wasn't you, and they will remember that. If they come out and you keep badgering them and you do all the things that you shouldn't do, they don't forget that. But if you call them before they come out and say, hey, I made a mistake, it's not you, I appreciate your willingness to help me, but it isn't you, and I don't want you to come out for nothing. Thank you very much, and let it end there. That goes a long way. If you convince the source is associated with power lines, number one, when they come out, if they don't ask to do it, suggest that they connect their equipment to your antenna. That's extremely important to figure out whether it's outside or inside, or to start the game. If they're going to look for the noise, they need to see what noise you have through your antenna. Your next door neighbor could be a ham and him have a totally different set of noises than you have, whether they're inside or outside. So it's very important that they connect to your antenna, see the noise that's coming in through your antenna. Okay. Yourself, do some hunting, suggest where the sources may be, but don't dictate to them. And if you see them going someplace other than where you told them to go, let them do their thing. Don't go out and correct them. There may be a method to their madness. I have a client in Tennessee. I would go to Tennessee before I was hired there. The ham would call me and tell me all about his noise. And he says, these guys from the power company, they don't know what they're doing. He says, I tell them my noise is to the north, and they come out and they go to the south. And he's telling me this for, a good couple years. Finally, I was hired to come to his home, and I found the noise from his antenna to be to the north. And I go to the north, and then a few minutes later, I'm driving south. And as I'm driving south, I look up at his door and I see him standing at his door shaking his head. I'm another one of those guys that won't go in the direction of his noise. Well, what had happened was the signal level from the source was radiating stronger from the north than it was from the south, which is where the source was. Because of the circuitry and the things involved in it, it made it look like it was to the north when actually it was in the south direction. And that's where I found his noise, very close to his house, but I found it there. And those are the types of things that you see that, being inside and watching them doing what they're doing outside, you may not realize what their methodology is. Okay. Um, One thing that gets very aggravating, especially when you're intimidated easily because you're having a hard time or you're not doing something right. All of us, as we get older, it's very easy to get frustrated because people don't have faith in you. So don't follow the investigator. If he's out there looking for your noise, do not follow him around. Don't drive around, following around your car. It's very nerve-wracking. Every time you turn around, you want to turn your car around or make a turn. There's somebody behind you following you around. Not a good idea. When I'm hired to find a noise, I make sure that the customer I'm going to see understands all these things that I'm telling you. Uh, when the linemen come to make repairs, don't follow them while they're making repairs. Don't stand across the street because believe me, if you're across the street, you're going to be telling him what you think is the noise, and it's going to be all kinds of stuff that aggravates the heck out of those guys. So you don't want to follow the guys around while they're making repairs. I have seen some really, really dangerous situations. A customer would show up on a job, lightning arrestor blew up. I was in Oklahoma. Lightning arrestor blew up, and the customer was standing there, and everybody hit the dirt but the customer. He's standing there like, what do I do? And he had no understanding that these types of things happen. You just never know. It can be a very dangerous situation. The next thing is do not instruct the lineman. Um, when I first started doing this, I would be in my car, the lineman's up in the bucket, and I'd be standing there listening to the radio in my car. And every time he touched something on the power line, I would hear noise and I would think that's my noise. Well, I didn't know any better. So I'd holler at him, that's it, that's it. It wasn't it, probably 10 spans away. It wasn't even close to where he was. But I would holler at him, telling him that that was it, and I was wrong. It's very frustrating to have that happen. Uh, uh, the next thing is don't suggest it's a transformer because it almost never is. It's very, very rare to find a transformer causing the noise. The reason why most people think transformers cause noise is because when you change a transformer on a pole, you disturb the whole pole. And chances are when that gets done, when he changes out the transformer, he tightens all the hardware and disturbs the noise. He may not correct the noise, but it might disturb it so it doesn't come back on while he's there, just to return a couple weeks later. So don't suggest transformers. They're almost never the cause. And I probably get more suggestions of transformer noise than I do any other piece of hardware, and that's almost never the cause. Very interesting. Okay. I tell this to hams and I tell this to commercial customers. I tell people this all over the place. Um, Consider the investigation cost is yours. For everything the lineman does, everything the interference investigator does, you have to pay for. Would you still suggest they do all those repairs? I have been actually years ago, I was bashed on the internet. I forgot it was Chicago or something like that because we located the problem to be on top of a 345,000 volt tower. And I told them that they needed to replace a part on top of this tower, and they did. And they wanted to replace the ones on every tower. And I said, no, that's ridiculous. There's nothing wrong with them. Don't just go out there changing everything, because for one, it'll create new problems, shaking all that hardware up. And I got banged up pretty good by amateur radio operators all over the country because I suggested them not to change hardware. So basically, what I tell them is, are you willing to pay for it if we're wrong? If what we do doesn't correct your problem, are you willing to pay for the time it takes to do it? That kind of changes people's attitude a little bit. They seem to start to understand where we're coming from. Okay. And most definitely don't tell them what to repair. When they're on the pole, um, I have to tell you, probably in the past 5 years, I may have had one person tell me what it is on the pole and they were correct. It's just not usually the things that are most obvious. Uh, it's and all that happens is if you tell them to do something and they do it and they're gone and it doesn't correct the problem, where do you stand? So it's better to let them figure it out. If you are 100% sure exactly what it is, and I don't know how you could be, but if you are 100% sure that it's something, let them know that you have a feeling it could be this. That way you're not dictating to them this is what it is, and they'll check that out. If they don't, they're crazy. They should, if a customer tells me where a problem is, that's probably one of the first places I'm going to go just so I can say I did, because like I said earlier, crow doesn't taste good. Okay. Very, very common. A high S meter readings doesn't mean you have power line noise. Um, I investigate complaints all the time, and it's very, very misleading. A customer has a S1, and then he calls me 3 hours later and says he's got an S3 or an S4. He's got power line noise, and I go and I said it's not power line noise. The noise, your S meter, your noise floor is just high in that direction, and I hook my receiver up that shows him a picture of the noise source, basically a fingerprint for the noise source, and it doesn't look like sparking at all. And I have to explain it to him. But just keep in mind, because you have an high S meter, it doesn't mean that it's a power line noise. It means it's noise to you, but that doesn't mean it's an AC noise or a power line noise. And just for reference, anybody listening, if you have questions, please write them down so at the end of this we can get them. I don't want anybody forgetting the questions you have because I want to make sure I answer everything I can. When I go to a customer's house, the first thing I want to see is what they have on their radio. This ham was complaining about 6 meters. The first thing I wanted to do was go to his receiver, turn it on 6 meters, see what frequency he's using, see what the signal level is, and any other characteristic about the noise that he has. Okay. What I will do is I will connect my receiver to his antenna after this, and then I'll set my gain. So my noise level, looking at his noise, is the same level as his. My receiver hears much better than the average ham receiver does, and it's a lot broader. So to equalize things a little bit, I set the gain so they're about the same. So his S5 is my S5 using his antenna. Okay. Now, how do we find the source? I see I forgot to do something here on this presentation. Number one, study when you connect. Well, now this is what I want you to do. You've studied the noise and the characteristics of the noise in your receiver. You look at the signal level. You watch the signal level fluctuate up and down, back and forth. You hear pauses in the noise and it comes back. Whatever the characteristic for your noise is, utilizing the antenna that's connected in your shack. Now you want to study these characteristics, know them well, record them. Take out your phone and record it. Take a shot like I did in this previous slide. Take a shot and record this video so you can refer to it while you're out in the field, because it's when you go out there or in your home or in the neighbor's home, wherever the case may be, you'll want to see that characteristic and see if it matches what you have. If it doesn't, it isn't yours. and that really does help. Okay. So don't try to identify the source by its characteristic. There are so many devices out there, so many things out there, such as power supplies, that are utilized in multiple different things. I once had a TV power supply, an LCD TV power supply, and a wind turbine. They were used for the pitch controllers on a wind turbine in DeKalb, Illinois. I heard the noise on the hands radio from Maryland, and I told him, I said, "Man, that sounds like an LCD power supply." And he was very unhappy. I wasn't insinuating that's what it was, but it sounded like it. Well, as it turned out, when I got there and I went up in the wind turbine, went into the nose cone, took apart the cabinet that controls the blades, and actually found the power supply that they utilized. Each blade utilized 4 power supplies. They were identical, the same part number as a TV power supply that I had repaired. And I took pictures of it. I sent the guy the note. I disconnected one of the 4. They had 2 parallel and 2 in series to get the right current and voltage, or right current and voltage that they needed for the pitch controllers. Uh, and so basically it was that. So what I'm saying is the characteristic could be for a power supply, but that power supply is used in 100 different things. So it really isn't going to help you to try to locate it that way. The best way to locate it is by locating where it is. Once you know where it is, you'll know what it is. So the first step is to use the How to Locate RFI in a Home. That's a handout that I'll have the link up here in a minute. That's a handout that I give people all over the country. Power companies use this handout all over the world. And if that doesn't give you results, then it might be in another residence or another building. Then I have the How to Locate the Residence. If you need that, you use that. Then you want to determine the address or location of the source. After you locate that address where the source is, then you return to step 2 and start the process over again by locating the inside issues. Okay, this is cutting me off a little bit. I should be able to remember this, but I can't because this up top of the screen is wiping out my score. Okay. Okay, so the first step of the process, you want to observe the interference as it affects your receiver connected to your station's antenna. So learn that characteristic, study it, know it like the back of your hand, and record it. Okay, and you want to analyze the RFI's audible and video characteristics. If you can hook up a scope to your equipment, it will do you a world of good. That scope will give your hearing eyeballs. You'll be able to see the noise and see the characteristics, and it's a lot easier to see than it is to hear the differences in the different characteristics. Okay, the next thing you want to do is connect a portable receiver to the station's antenna. And again, observe how it affects this receiver while connected to your station's antenna. Okay, so you looked at your radio, you studied the characteristics of your noise. Now you want to hook a portable radio up, whatever radio you would use to walk around your house or walk to the next door or walk down the street. Now you want to connect that to your antenna, the same antenna that was hooked to your station radio. Okay, now you want to hook it up to that, and you want to study the way it is and the way it sounds in that receiver. All receivers, the noise doesn't sound the same in all receivers. So you want to get used to the noise and how it sounds on the antenna that's receiving the noise. Now, it's important to have a DC powered radio for this process, but don't rule out the fact that it's just as important to plug it into your shack. Some of the noises you'll get on your receiver come in through the AC. Many times people from utilities will call me and tell me I'm connected to their antenna. They have noise on their receiver, but I don't have any on mine. And the first thing I say is, have you plugged your receiver in? They say, no, I'm on battery. I say, plug it in. Get your power supply, plug it into the outlet, and see what happens. And most of the time, the noise is active on their receiver after they do that, because a lot of the noise is coming in through the AC. Okay. Now you're going to use this receiver, this portable receiver throughout the search, whether you're in your house, next door, walking down the street to a business or wherever the case may be. So it's very important to be familiar with the sound of this noise and the characteristics of the noise using the portable receiver. Okay. Equipment needed for locating. You need a receiver. I know that shocks you. You need a receiver. This receiver you're using should have a port for an external antenna. Okay, a lot of receivers don't, but it's very important so you can utilize different types of antennas in different scenarios or on different frequencies. Um, and you can also utilize that for if you need to amplify it because the noise is so weak. Remember, the antenna on your shack has a lot more sensitivity than what you're going to have in your hand when you go out on the street. So if it's not in your house and it's in a neighbor's house, you may need that added sensitivity to overcome the weak antenna that you have. Or it could be so strong you need to attenuate it. So having a BNC or some other type of RF connection on your receiver allows you to add either a PA or an attenuator in line. Sometimes you'll start with one and end up with the other. Okay. Battery and AC powered. That's very important. You want your receiver to cover the frequencies affected by the RFI. So make sure your receiver, you can at least start with the frequency you're dealing with. Some of these noises are very, very narrow, and it might not affect any other frequency. It's not uncommon for me to get a complaint on the AM broadcast band. The noise is at 530 and it's going at 540 and nowhere else on the band. It's very common to find HVAC systems with circuitry in them that's very narrow. Okay, receivers. Here's a few I'll recommend, and I've talked with 3 or 4 people in the past month that have purchased these on the internet. The RE Radar Engineers Model 243 is the newest. It's the latest and greatest. It's fantastic, and that'll cost you a lot of money. Those things are probably $9,000 now or something. I would be shocked to see something that's economical on a 243 on the web. The 242s are getting very popular on eBay and other places on the web. That's the predecessor to the 243, obviously. It's a very good receiver. It has a couple of quirks about it, but it's still very good. If you can get one of those, typically they're anywhere from $700 to $1,000. The 240 is also a very good receiver. The problem with the 240 is it doesn't do 180 meters, 160 meters. I hope I'm the only one hearing that. It does have a scope on it. All these, except for the 245, these all have oscilloscopes on them, and that is really a nice feature to have. Okay, the 245 is a small portable device that you hold in your hand. It's got an antenna and it's got HF and what is it? HF, I forgot what the two positions are. But it's great for locating noise inside. It's good to use at a breaker panel. You can narrow down what breaker it is without turning breakers off, and that's really nice. And there'll be a picture of one of those coming up soon. Antennas. Antennas are one of the best and strongest features of an interference investigator's tools. This is the one thing that can make or break you. How you use the antenna, what antenna you use are extremely important. I think in 45 years, I have never stopped working on small portable antennas to locate things. I'm in the process of building one now for 340 kilohertz to locate a noise at a cattle farm in Texas. So there's never an end to this. When you think you'll never need anything that low, something pops up, you know. Antennas are very important. You want an antenna that'll work with the frequencies that are affected. A small vertical HF antenna, 75, 80 meter antenna is great for mobile work. It's not great to walk around with because it's 10 feet long or 8 feet long. But there are varying degrees and compromises to that. Directional antennas, anything directional is always great. Whatever you can use directional certainly enhances the process. And you want those to be hopefully effective on the frequencies that you're dealing with. And there's quite a few out there now. DX Engineering has a couple now that that are pretty decent. I'm in the process of checking some of those out as well. Okay, this is something that I do on almost every investigation that I perform, and I do this before I get there. I draw a map, typically close to 2 mile radius, and then I draw the compass on the map. So if I'm at their house and I swing the beam around and it says 80 degrees, I can look at my map and I can see exactly where that beam is cutting through the neighborhood at 80 degrees. And then I go in that 80-degree direction, and everywhere that line crosses is where I go. Uh, this is true with inside noises and power line noises, although it isn't very helpful with an inside noise if it's very close to you. And most inside noises are going to be very close to you. Most commonly in your house or the next door neighbor, or at least someone on the same transformer that you're on. So this isn't very useful. Not only is this not useful, but directional antennas, when you're using a directional antenna to point that to the direction of the source, if the noise is inside a neighbor's house, it can be very misleading because typically your antenna that's directional doesn't work very good when the RF is coming from underneath of it. So the noise can tell you your antenna can tell you it's to the south when really it's to the northeast because it's picked up off the element that's closest to the house where the noise is. That's a very, very common scenario, so beware of that. Okay, locating inside sources. There is on my website, this is the link to my website. If you go to rfiservices.com and go to sources, there's a page there that tells you how to locate inside sources. This is the page. And basically this tells you to go to the house or go in your house, go to the breaker, turn the breakers off one at a time till you de-energize the house. And this has a whole lot of very invalid points and important things to do before you do that. And a lot of disclaimers in here, don't attempt to remove cartridge fuses unless you're, experienced and things like that. A very common sense approach. Now that's a word you don't hear anymore, common sense. It's not too common these days, is it? But this instruction sheet is used by a lot of power companies, and this is what they will send out. If you call in a complaint, a power company would send this to you and give you instructions on how to locate it. If 80% of the noises they go on are found to be inside the complainant's home, this is a very good step to keep them from having to come out. And it works. It has eliminated a whole lot of unnecessary work for power companies. Okay. Now that is this is on my website. It's free. You click on it, it'll open up your word processor. You can print it, you can manipulate it, you can change it, you can do anything you want, but don't put my name at the bottom of it. I don't want all the people that you're investigating noise for calling me. I have enough. But this gives you some suggestions as to what the problems are and so forth. It's very good. I started using this. I started with the print that comes from the FCC back in the 80s, probably even the 70s. And then every time someone would call me and ask me a question, I would rewrite it. And I did it so many times, nobody asks any questions about it anymore. So I guess it's pretty self-explanatory now, and it does a pretty good job. Some of the sources from time to time change. I had them at one time listed. These sources I had these sources right here listed in order of most common to less common, and that changes, from time to time everywhere you go. Okay, I think we'll probably lightly touch on this later. So when you're approaching your breaker panel to eliminate your home, the most common comment that I get is, I've turned off everything in my house. Very rarely is that really the case. They go through their house turning off TVs, turning off lamps, all kinds of stuff. And it's amazing. Some people just don't realize when you turn your TV off, it's not off. If it were, your remote wouldn't work, right? I mean, this is a very, very common scenario. And I know all of you are thinking, man, this guy must think we're dumb or something. No, that's not the case. This is case in point. This happens all the time. So when you want to eliminate your noise, you use your receiver at this breaker panel, the portable, and you go down the breakers and you turn them off and on one at a time until you turn off one that stops the problem. Remember which breaker that is, turn it back on. When your noise returns, find out what room that breaker controls, go to that area of the house, and just follow the instructions that I just passed. It'll get you there. This is the circuit sniffer, the model 245 I was telling you about. Does my mouse show up on here? Somebody? Can you see my mouse?
Yes, we see your mouse.
Okay, good. That's my mouse. Don't kill my mouse. This 245 has a probe on the side here. On the circuit board in this is a little coil, and as you run the coil up and down the breakers, the signal level gets stronger as you approach the breaker. So you turn the gain control down as you're sliding this up and down until you figure out which one has the strongest noise. Then you go back and forth because these two breakers are on the same bus, and these two breakers are on the same bus, and so forth. So you want to go back and forth, and you can eliminate the chance of turning off a breaker other than the one that's causing the noise, and it works pretty good. It has a signal level meter. It operates off a 9-volt battery. It has a light that turns red if the battery's getting dead, and it has 3 positions: HF, LF, and the probe. One of the things I did to mine was I took it apart and I shielded this box because the box is plastic. Well, the probe is right here and the hole has a plastic plug in it, and it didn't make any sense. You know, I figured this would work a lot better if I shielded the box and just left this unshielded, and I think it enhanced it a tiny bit. But this is a pretty good device, and I've never looked for one of these on eBay or any place like that. So I don't know how many of these you might find around. I get people calling me from time to time. They have them and want to know what they are and want manuals, and I help them out with that. But I've never looked for one of these, so I don't know how often you find one. But this should be relatively cheap. I think these are probably in the $400 to $500 range or something like that, new. So I'd say, you know, $150, you could probably get a used one, hopefully. Okay, locating the residence with the source. This link will take you to my website, to the source, to where this literature is. However, basically what this tells you is if you want to find the house, the townhouse, the apartment, whatever it is that has the source of your noise, basically what this tells you to do is to leave your house, go to the breaker panel or go to the meter at your house or whatever is equal at all the homes. So you can go to the breaker, but sometimes, or not breaker, you can go to the meter, but sometimes meters are behind fences, they have dogs, and you look kind of funny walking up to the side of the house when there's a window right beside the meter. People get a little suspicious. I could go on telling you about those experiences all day. Well, utilize something at the house that's common at all the homes. For instance, if you have a front porch light, okay, every house on your street has a front porch light. That would be the antenna for your noise. If you have a lamp post in the front yard that's electric, you can walk up to that lamp post, measure the noise with your receiver, then go to the next house. If the noise is in that direction, it's going to be getting stronger. Okay, so you turn your gain down and continue on the process until you go to one lamp post that has the noise and the rest of them don't because you've turned your gain down so far. The others are too weak to be received. Okay. Now, there you go. Mute old Fred. You can also, in apartments or townhouses, condominiums, you can utilize the air conditioners outside. You've got an HVAC system that are usually in rows outside the building. Each one of those HVAC systems are usually powered from the apartment that it belongs to, or at least the low voltage circuit will be coming from that house. Okay. So, or that unit, that apartment, the condo, whatever it may be. So the noise will be strongest at the air conditioner that houses the noise problem you're looking for. So you go down the row of heat pumps or whatever the case may be. You find the one with the strongest level of noise. You match it to your noise. Then you find out what apartment that connects to, and go in and utilize that approach. That's very useful. In apartment buildings, you have all the meters. Typically, all the meters are in a room. Condos are the same way, and sometimes townhouses are too, the older townhouses. If you carry your receiver down this row, as you carry your receiver down this row, keeping it at the same place at every meter, it'll be very obvious which one houses the problem. If I come to your house and you live in a situation like this, and I find that I get right here and the noise is strongest here and I don't hear it anywhere else, I'm going to turn this breaker off and back on again. If it interrupts that noise while it's off and on, then I found you. That's your noise right there. And in my opinion, this is no worse than a momentary outage. Nobody pays any attention to them if it happens one time. And I'm not going to hesitate being able to find this noise that fast. I'm going to turn that breaker off and on. If it does it, then I go knock on that door. Apartment number 2 has the noise. I go and knock on the door. Okay, the investigation process. Make sure that you return to your station to verify your RFI signature was eliminated and the possibility of any other sources. That's very, very important. Okay, now this is one of the weak points to this whole process is you have to go out and knock on some doors. And that's not for everybody to do. Some people don't feel comfortable doing it. And if you don't feel comfortable doing it, maybe it's not your place to do that. But once you are 100% sure that you have the correct location, you know that the noise is in this house, you've been to their front door, you've been to their meter, you've been to the light out at the street, whatever the case may be, you know that the noise is at this address. Okay, this is what I do. Okay, holding the radio in my hand with the display so it can be seen and the radio on, the noise is active, and I turn the volume down so it's relatively low, but they can hear it. It'll be very obvious. When they open the door, they're going to look at you and they're going to look at the radio. Okay, they're going to keep looking back and forth between the two. So I introduce myself. Okay, if I am the ham that's looking for the noise, I'm not Mike from RFI Services, but if I'm you, I say, hi, my name is Mike Martin. I'm searching for a radio interference signal that's affecting a licensed radio station. The noise you hear in this signal is the one I'm searching for. I'm getting a very strong level that I believe is coming from your residence. Now, this could be your office, your location, whatever the case may be. Okay. And then I tell them these interference signals are very easy to locate by going to your breaker panel while listening to the signal and turning off and on your breakers at one breaker at a time. Okay. Turning off the breaker will de-energize the cause of the noise, making it easy to locate in the area that the breaker controls. Okay, often the offending device is malfunctioning and is found to be a fire hazard. Now, the whole time I'm doing this, I have this information sheet in my hand, trying to give it to them. I'm handing it to them. When they first open the door, I introduce myself. I say, hi, I'm Michael. And I start explaining to them and I say, here's an instruction sheet. You can do this yourself. This was designed for everyone that owns a home to do on their own, or I can do this for you. There's no fee for it. I just want to find this noise that's affecting a licensed radio center service. And I think probably in 40 years, I've had 2 people not want me to come into their home to solve these problems, to find these problems. And that was very particular situations that kept that from happening. But most people want to help, especially when they know this is a fire hazard. Now, here's something that I don't put on there because I don't want to I don't want to scare people, but it's something that I typically end up talking about. And this is a very true scenario. If I knock on a customer's door, if I'm representing a power company and I knock on someone's door, let's say I come to your house and I say, you have a noise device, you have something making noise in your home. I think it's something that's arcing in your home. It's an arc, and I can tell from outside whether it's an arc or whether it's not. But if I feel it's an arcing source, and I can see that on my equipment, the 60 hertz sign and the spikes and all that stuff, if I see that and I tell them this, and they say, no, I'm not going to let you in. I say, well, let me explain something to you. And this is a true story. I've been here before, not here, but I've been in this situation before, and the person wouldn't allow me in their home. When the fire department came to a fire at their home, the first thing they do is they want the power company to turn the power off. The power company shows up, turns the power off. Then during the investigation by the insurance company, they find out that the power company had been there and warned them of this. They will not file, they will not cover your claim, and you'll end up going to court. And I have been in that courtroom when this has happened, for both scenarios, going both ways. And it's not pretty. It's pretty tough. But that's a true scenario. If someone says, and it's documented, that you have a device in your home that you believe is an arcing source, and it turns out to be, and it catches the house on fire, their insurance company won't cover them. They will battle all they can to save that $500,000 home, then they have to rebuild that home. Not to mention hotels and all that kind of stuff. And that's a true scenario. I've been to court more than once for that type of thing. So it's very important for for their safety, and maybe even yours, depending on where it is, to find this offending device. And it explains this in that handout sheet that I have on there. Okay, just to recap a couple of things, and I get these questions all the time. When you're looking for a noise, power line or not, power line or inside a house, do your leg work. Don't take anything for granted. If you're pointing at a pole or a structure that has noise, use a directional antenna. These are VHF antennas, 143 megahertz. I had designed just for this purpose. They work very good. And make sure that what you're pointing at is your noise. Be 100% certain. And keep in mind, if you had to pay for it, would you point your finger at that device? That's very important. Another scenario is another tool that's used frequently by hams as well as the utilities are the ultrasound detector. This is a 42 kilohertz receiver. We want a dish. A lot of these are being made. The problem with the kits that are being made is they're very insensitive. They have very low sensitivity. So they only hear the most obvious sources, the things that are direct line of sight, and typically they're things that do not cause radio interference. It's very common for these dishes to pick up insulators that have corona discharging from them, but that is not a gap type noise, and it doesn't interfere with your radio. It's very common, so keep that in mind. If you're using one of the MFJs, it's great to have this thing, but keep in mind that what that thing points at isn't always a sparking source. There can be more than one type of source that they pick up. Let's see. I can't think of anything else I meant to cover. I guess if it's good for you guys, I'd be more than happy to take questions.
Mike, that was a great presentation, and I did see one question about the manufacturer of those radios that you had referenced, who that was.
Radar Engineers in Portland, Oregon.
Okay. Someone asked for the links to be shared again. We'll put those on when we publish the video. We'll get those links there for people.
Yeah, that's why I put them on the slide, because I had people referencing things I'd mentioned in the last presentation.
Yep. So, Mike, just to start off the questions, would it be a good idea? Would it be just a second, Tom's making. Would it be a good idea to do kind of a survey of your own home, even if you don't think there's a lot of noise, just to get used to the process, and maybe you'll find a bad power supply that you just haven't run across yet for RFI, but it's there.
Well, it's very common for me when I go to a customer's house, if I'm hired by a power company across the country, when I go, and it's typically hams that I'm hired to resolve the interference for. When I go there, one of the things I normally do is go to their breaker panel with a receiver, my 243 with an antenna, short telescopic antenna, and I might be at 160 meters, I might be at 80 meters, and I'll show them the amount of noise and what happens when I turn their breakers off, and most of that noise goes away. Now, keeping in mind that I'm right next to the load center, so the noise level is going to be a lot higher there than it might be coming through their antenna or through the power into the rig. Plus, most people have filtering in the power coming into the rig anyway. But yes, that's a very good point. You might be amazed at how many noise sources you have in your home. it's not uncommon at all for me to travel across the country to find something in a ham's house that he's been blaming the power company on for 10 years. Um, there was, I may have mentioned it the last time on the last presentation, but I was hired. I went to Alaska and found a noise that the guy had been complaining about for 10 years. And they had been looking for it for 10 years, and it was in his house. The bill for that investigation was $750,000. Not my bill. I wish. Not my bill. But the amount of money that they spent on that investigation trying to find that ham's noise was $750,000. And it was a fluorescent light in the ham's basement. As far as the ham knows, it's always there 24 hours a day because when he leaves, his radio's off and he turns the light off. He comes back in, the first thing he does is turn the light on and go turn his radio on, and the noise is there. So he was saying it's there 24 hours a day. So, yes.
So we have a question from Steve, and he says, don't forget that turning off the circuit breakers leaves UPS backup power active.
Absolutely.
And I know for myself, I probably have 10 or 12 UPSs around the place,
How about that?
just keeping them operational. So,
Yep. Yeah. I took a trip to Nashville. It's probably been 3 years ago, to resolve a ham's interference. And I sat at his desk and he went out and killed the power outside his house. And I still had noise. And he came back in. I said, you still got a noise source in here. He said, no, I don't. I said, yes, you do. I said, you got an ups unit. He said, no, I don't. I said, oh, you do. I'm looking at it. It's right here. I see it on my radio. And, and then I looked around and all of a sudden I could hear a fan running. And I said, your power's off, right? I said, what's that fan running? And he looks at me and he gets this weird look on his face. He says, it's an ups unit. I said, it can't be because you don't have any, right? But yeah, that's very common. Very common.
Got a couple questions.
Ed, let me just go through the list real quick, then we'll be back to you, because some people wrote some stuff down. One is, I had a ground loop in my house with the white shorted, I guess the neutral, shorted to ground in a second floor ceiling light. The noise was real bad. Have you seen this?
Well, I have heard that probably 1,000 times. And the neutral in the panel is connected to the ground. So that occurs in every home. So that's not an issue. No, I have never heard of a noise being created by that, and I have never eliminated a noise by removing that. Now I have eliminated a noise by removing the ground off of equipment, because the ground is what's carrying the noise. But no, as a ground loop being the issue, I have never found one to be the cause.
Okay. Ed, go ahead.
Okay, kind of a couple questions. Let's start with the first one. Everybody that's ever operated HF has got issues with noise. Now, every club used to have people that were specialists and almost committees. What would you recommend? You don't see much of it anymore. What would you recommend for a club to start up a committee, an RFI committee, to what they need and what they need to learn to be able to go out and get going on doing some RFI work?
Well, it's interesting you say that because I have a club in Florida. Actually, one of them just came. I have workshops in Pigeon Forge every year, and one of their members came to my workshop in Pigeon Forge. They got a grant for equipment from someone, and I don't know what organization gave them a grant, but they paid for one of them to come to my workshop, and are going to pay me to come down and train them so they can find noise for several different ham clubs in Florida. Um, Basically, the equipment that I showed you there, and the ideal situation would be to have a 243. That's a radar engineer's 243. That's unrealistic for most people unless you're making money with it like I am. The 242 is a very commonly available radio, and they're going to be more and more available. I imagine I'll probably have a couple. Oh, in the next, probably in the next few months, I'll probably have a couple of them myself to get rid of. The 243, that's a receiver that has, it covers from a half a meg all the way up to 1,000 meg. It has the ability to record noise pulses. It has the ability to record video of no, not video, just noise patterns. The 243 actually records 20 seconds of noise, active noise video. The other thing would be a VHF antenna. If it's power line noise, I wouldn't dream of going out without a VHF, my VHF antenna. And I've been using, for years, I've used a TV antenna that I modified. It's called a Ghostbuster 3619. I modified that to work at 143 meg, and it works wonderful. At that frequency, you don't have any ham activity to interfere with you, and there's nothing, typically there's nothing else there unless you're right by a military base. Sometimes you'll get a little bit there. The 75-80 meter whip, who did I say? I was on DX Engineering yesterday. I can't remember the company. I can't remember the company now. I was a little surprised to see the company that has them now. But it was MFJ. 75-80 meter whip is a fantastic antenna to use mobile because it's very sensitive to noise at a greater distance. Noise travels further at lower frequencies, so that's a pretty good antenna. If you want to go to 160 meters on the antenna, you can, but the antennas are pretty big. I think an outbacker is not too bad. In my business, anything that has a connection is a weak point in the equipment, so I don't use the outbacker. I don't like to use hustlers because of the resonators. I can have problems with them breaking and so forth. The dish is a very good enhancement to the process, but you really have to study that because typically most people get misled with that, and they're pointing out corona on insulators and things that aren't the problem. So it can be very misleading unless you really use it a lot and get good at identifying the sources. Did that answer your question?
Yeah, you're doing well. The other question I had that fits in with this, you've mentioned this RE 42, 30, 50, whatever. Have you had any experience with the modern nano SAs and the SDRs, using those for portable equipment?
No, I haven't. I have a lot of different things. I just haven't gotten the opportunity to use them yet. I just purchased an IC705 because of the 340 kilohertz interference thing. I'm working with some ear tags on cattle, and they're not being read, so I need to go down in frequency. And the SDR covers that frequency range. I just don't have the time to utilize it and get used to it. I'm not a person with an overabundance of time to figure things out. You know, you show me a piece of equipment, show me how to use it real quick, and I'm on the way. Well, one of my buddies here in Maryland had this 705. I used it and it worked beautifully. Plus, it has a scope on it, which that's one less piece of equipment I have to carry. So I purchased it and I've been playing with it for the past couple of days, getting ready to go on vacation. And I think it's a pretty useful tool and used along with a laptop. It enhances a lot of the features it has. So I'm hoping to be able to manipulate the oscilloscope and synchronize things a little better than what the radio itself does.
Okay, the only other thing was kind of a third question, but it's not really a question.
Go right ahead.
Is just mentioning that doesn't ARRL have an awful lot of literature available for folks to read up on RFI?
Yeah, actually they do, and there's a couple of people trying to get them to republish Marv Loftus's interference handbook. There is several books out there written by Marv Loftus. KB7KK is his call. He was my partner, my business partner, associate for many years. He passed away. A brilliant man. He probably forgot more than I'll ever know, and he wrote several books on interference. Now, there is a new book out, just came out this past year. It's available through the IEEE, and it's called the P1897, P1897, I'm trying to think of the way they worded it. If you go to IEEE and look up P1897, you'll see it. The book is kind of expensive. I think it's $100 and some bucks. This book was just written by me and 14 other people. We spent 5 years, a little over 5 years writing this book. It's a fabulous book, and it covers every aspect of locating interference sources uh, via basically what a power company would want to do. It's very meticulous, very involved. It even has some of the things from foreign countries and their rules and regulations and so forth. Uh, this will be the Bible. It will be what utilities follow. It tells them how soon they should respond to your call, how soon they should be on site, and how soon they should find it, and how long they should take before they hire somebody to train them or find it for them. It's a really, really good book, a lot of good illustrations, a lot of photos, a lot of references for other material, a lot of pictures of equipment and procedures in there. It's a really good book. That's the P1897 recommended practice is what they call it, but it will be a standard.
Okay, thank you, Mike, and I've worn out my time.
All right, thank you, Ed.
Mike, that leads into another question from one of our participants. And he says, I've often found that on the 6-meter band, the noise is very easy to identify as power line and very disruptive to weak signal reception, but has little impact on the S-meter reading. Yet the power company sees the low S meter and just shrugs their shoulders. What to do?
Well, S meter levels are a problem. As the FCC states it, it's kind of a messed up situation. The FCC doesn't have standards or levels for interference. They refer to it as harmful interference, and that's up to the interpretation of the investigator that comes out. I've been in many different positions with this issue, and it's very, very frustrating when you see a man that's close to 100 years old and his life consists of sitting in his garage talking on his radio every day, and the FCC comes out and sees that his noise level is the equivalent to about a 7 to 9, and he touches the sensitivity knob and the level goes up to 20 over, and he says, well, he's got faulty equipment. That's absolutely absurd. And I was there when that happened. That happened in Tampa, Florida. So there's no standards as to what level a noise can be. And when I cut my teeth in this job in the 70s and 80s, the utility stance was whatever causes the customer's noise, you find it, you do what you can to assist them to repair it. You don't walk away from anything. And I was taught that. And it was a great way to teach somebody, and it was a great attitude to have toward your customers. There are very few power companies that feel that way. They don't want to hurt. They don't want to touch anything that's after the meter. In his situation, I just spent 3 days in Florida working on a 6-meter interference case, and I find 6 meters. It's like it's a very easy band to work with for noise. They're easy to locate, and chances are, if there were a higher level of noise, if his S meter was a 5 or a 7, which is very easy at 6 meters, chances are they wouldn't have been able to find it anyway. If they could find it and they were willing to do that, it wouldn't matter to them. It would matter to them whether it was a S1 or an S2. And I can tell you this, on 6 meters, if he can hear it, if it's very distinctive in sound, I would try hooking up another receiver, because typically if you can hear it on 6 meters, you usually got a pretty good signal. I would be concerned that the signal level meter is inaccurate, because I mean, I've dealt with 6 meters for many, many years and did a lot of work with 6 meters. And typically when you get a noise on 6 meters, they're easy to find, and they present a pretty good level of noise. It's very unfortunate for him to be in an area where his power company doesn't want to be more active in locating it, because those noises like he's talking about are what make you good at locating. I work for people who have noise. I'll travel, I get to their house and their signal level meter is not moving and they got a noise and I got to go find it in a very busy area. And I might have to travel 3, 4 miles to find it, but I'm looking just for the sound of the noise. If you got a sound, you don't need an S meter. You can record the sound. You can record the pattern from the sound and go out and match it. It's in a direction, especially with 6 meters. I'd bet he has a beam. And if he doesn't have a beam of vertical, that means it's even closer. So you wouldn't have to travel as far.
One more question, and I guess I'll preface this question with, there are some issues that I guess you should be talking to your electrician about as well. And the comment is, neutral to ground short in a sub panel that caused a problem that I found. And my recollection is, if the sub panel is within so many feet or in the same building, you're not to have them together. It's only done once at the main breaker. But I guess the question is if there is a problem like that, what would you say if you found somebody that had an electrical code violation? Maybe that's a better way of stating it.
Well, there's a lot of variables there. Obviously, this is part 2 to the question a few minutes ago.
Yeah, it is.
I got it.
Can I make a comment?
Sure.
Absolutely.
Yeah, this was a situation where we had microwave equipment in the main building and a RF front end out in another building with a sub panel, and they had shorted the neutral to ground, and there was a strobe light on the tower. And when that strobe light strobed, it went bam on the power line, and we had current on the neutral, which also flowed back on the shields of the coax. They had fought this thing for several years, and when I hired on, I also had a lot of power background, so I started looking around, and I removed one green screw, which cost them about which had cost them before I did that about $50,000 worth of replacing equipment. The point of this comment is a lot of times a ham shack will have a sub panel, and you need to avoid connecting the neutral to the ground.
And
I would say that somewhere in that building where you removed that screw, somewhere in that building, the ground was being utilized as a neutral, or there wasn't sufficient neutral to return, and it was using the ground. There's more to that, because I'm here to tell you, I've done a lot of electrical work. I've put in a lot of sub panels, and I don't think it makes sense not to use that green screw. Now, I can tell you about a whole lot of things that I do when I do work, and I do tower work and electrical work, that most of the people on this on with us here would disagree with. But I only do things that I know work the way I did them. It's not a guess. I do it and I have great results, but I know people wouldn't agree with my way of thinking. But I've installed that screw in many places in sub panels, many times in sub panels, and never had a noise problem from it. However, if and there's another scenario or another issue with this is, we ground, we shield, and we put our equipment in steel boxes to shield them, and then we have noise on that ground, and it just saturates the equipment that's surrounded by the metal box that we put it in that's grounded. There's no way to get away from this stuff. But excuse me, I would be willing to bet that there was another problem in that building, and it was probably a code violation, not intentionally, but a mistake. But I would be willing to bet that the current's flowing on that ground instead of on that neutral where it should be, and that screw was allowing the path to return on the ground instead of the neutral. Because that ground
Exactly.
should not be a return.
Exactly. And the point is, it's a code violation to put that screw in a sub panel.
Yeah.
And that removing it fixed the problem.
Right.
Now,
And I've worked in Green Valley, by the way. There's a Green Valley Power Company, isn't there?
well, actually, it's Tucson Electric Power, and there's another one too, which I can't remember the name of. But this was in Juneau, Alaska, that I did that I found this problem.
Yeah, I've been there.
Yeah.
I may have even been where you worked in Juneau.
Well, it was at the Fish and Game place, where we had a microwave tower. I worked for the state telecom group, so.
Gotcha.
And Will, you asked if you could make a comment. Are you still with us?
I am. I'm still here.
Hey, there's Will.
Have a few things. I dealt with the local utility with power line noise, and you have to be extremely persistent, like Mike said. And I will say that don't be afraid to go to the Public Service Commission or whatever the entity is that regulates that. It really makes a huge difference. I am now from 20/9 to S7, which to me S7 is still not good.
No, it's
But
not
when you've
good.
dealt with S9 plus, S7 sounds like a heaven. But what I will say is, and I've learned a lot today in a short amount of time, it's hard to pinpoint. I live within 2 miles as a crow flies of 3 10-kilowatt AM broadcast radio stations. Not everything is utility, but ground is everything. And it's amazing what you learn in a short amount of time. And this has been educational. Even what Mike says, it's been a big, huge help. I have no clue where I'm going next. But thank you, Mike. I appreciate it. And this is I'm going to go back and read part 1. Thanks.
Good. Thank you.
Great. That's all the questions I had on the chat. I think I caught most of them. And again, I want to thank Mike. And we'll get those links up, including the IEEE link. And I wish everyone a quiet, peaceful, RFI, weather-wise evening. So, final comments? All right. Thanks, Mike, and
You're
good
welcome.
hunting.
Okay. Thank you, Kevin.
Thank you.
Thank you, guys.
Thank you.
Thank you.
You're most welcome.
Thanks, Mike.
Thank you very much, Mike.